Welcome back. So we're going to finish up our look here at letter F, evaluating these expressions, mostly trigonometry stuff with a little natural log and E there in 16, 17, and 18. Okay, so let's continue our look here. So arc trig functions, as you see right here, or even tangent inverse, which is the same thing as arc, those are the inverse trig functions, okay? They work backwards from our normal trig functions. So a normal trig function, right, like sine, for example, the input is an angle and the output is a ratio, right? But for inverse trig, like arc sine, those reverse. The input is a ratio and the output is an angle. So you can see here, right, that's a typical ratio of root 3 over 2. We're plugging into the arc sine there. And so what we're really trying to do here, when we evaluate arc sine, one way you can think about this is we're trying to determine, or another way you can think about this is sine of what gives us root 3 over 2, right? Asking arc sine of root 3 over 2, right, what does that equal, is the same thing as asking sine of what gives us root 3 over 2. So what is that? Well, let's go to our special right triangles up here. So here's root 3 over 2, right? How do we get that using sine? Well, sine, remember, is opposite over hypotenuse. So this is opposite what angle? Pi over 3. And the hypotenuse would be 1, and that would give us the right measure there. So it's just pi over 3. Okay? There's our answer. Now, one thing we have to be careful about when it comes to arc sine and the other inverse trig functions is that arc sine and arc tangent, these both have a range of negative pi over 2 to pi over 2. Whereas arc cosine, this has a unique range of 0 to pi. Okay, so when you answer an arc sine or arc tangent question, you have to give your answer between negative pi over 2 and pi over 2. Okay, if you're answering an arc cosine question, you have to answer for an angle that works between 0 and pi. So let's continue here and take a look at how that's going to work out. So tangent inverse of negative 1. Okay, so if we look up here, right, if I do tangent of pi over 4, that's going to give me a positive 1, right, because it'd be root 2 over 2 over root 2 over 2. So that'll be the same thing as 1, right? So pi over 4 would be our answer, but we need a negative 1. Okay, so negative pi over 4 is what we will write then for our answer. Okay, positive pi over 4 gives us positive 1. When you do the tangent of pi over 4, you get positive 1. So when you do the arc tangent, or we do tangent of negative pi over 4, you're going to get negative 1. And that's going to be our answer there. Okay. Arc cosine of 0. So again, we can't really use our special right triangles for 0, so we kind of have to go here. All right, and we can see, where do we get a cosine value of 0? Well, cosine here gives us a 0. Cosine here also gives us 0. But which one can we use? Well, we can only use this one because that's the only one that fits in the range for arc cosine between 0 and pi. Okay, so we have to use our 90 degree or pi over 2 angle. Okay, this would mean technically, you know, that would, a cosine of 0 is, a cosine of 270 or 203 pi over 2 does give us a 0 there. But we can't use that because, again, it's the wrong range. 270 or 3 pi over 2 does not fit between 0 and pi. So we have to use this one right here. Okay, cosine of 90 or pi over 2 gives us that 0 there that we're looking for. And then arc sine of negative 1/2. This one we can use our special right triangles for. So let's treat like it's arc sine of positive 1/2. Remember, arc sine, a sine is opposite of hypotenuse, so it would be opposite the 1/2 and the hypotenuse of 1, so that's going to be our pi over 6. Again, though, we need a negative 1/2. So to get that negative 1/2, okay, so again, there's our sine. Sine of 30 or pi over 6 gives us the 1/2 there. We need the negative 1/2, so that's going to be this angle right here. Again, 11 pi over 6 or 330 does not fit in between our range, but if we go back this way, pi over 6, then voila, that's how we're going to get our answer. So it's going to be negative pi over 6. Okay? So how can we kind of help ourselves out here a little bit? So really, when it comes to arcsine or arctangent, if you're taking the arcsine or arctangent of a negative number, so like here we have arcsine of -1/2, here we have like arctangent of -1, you can just act like you're finding the positive one, so find tangent inverse of +1, find arcsine of +1/2, and then just make your answer negative. Okay, so tangent of +1 would give us a positive pi/4, so then -1 gives us negative pi/4. Okay, arcsine of +1/2 gives us a positive pi/6, so then arcsine of -1/2 would give us a negative pi/6. Okay, when it comes to our cosine, it's a little bit trickier. You just have to find the, if it's a negative, if you're doing the arc cosine of a negative number, whoops, just find the second quadrant equivalent angle. So for example, if you want negative pi/6, then imagine just doing it for the angle of 5 pi/6, which is the second quadrant equivalent for the pi/6 there. Or sorry, not negative pi/6, sorry. You wouldn't do it this way. Sorry. It would be arc cosine of like -√3/2. Okay, so treat it like it's positive √3/2. So that would be the 30-degree angle there, but you want the second quadrant version of that, so it would be the 150 or the 5 pi/6. Okay. In calculus, right, we don't really work with degrees, we work with radians. So you're going to want to really be familiar with those radian measures as well. Okay. Lastly here, we've got our E and natural log stuff, and this is just a brief review of some of those logarithm properties. Okay. E and natural log are inverses of each other, so they cancel each other out. So when we do e to the natural log of 4, then our answer is just going to be 4. Okay. Natural log of 1, a little bit trickier to think about, not using inverses and stuff like that. But you could use an inverse to cancel it out. So for example, we could put like an x here and use an e to this side and an e to that side to cancel out. We have a 1 here and we'd have e to the x here. And the question is, e to what power would give us 1? Well, how do we get how do we get 1 as an answer when we don't know our power? Any number to what power is going to give us a 1? Well, it's going to be 0, right? So the answer here should be 0. Okay? Because e to the 0 gives us 1. Okay? Technically, a 0 to the 0, it does not give us 1, but that's another story for another time. Lastly here, the natural log of the square root of e. All right, here we can use some properties to help us. For example, the square root is the same thing as e to the 1/2 power. If you remember your properties of logarithms, right, we can bring that 1/2 power out front here and make it 1/2 natural log of e. The natural log of e, those are inverses of each other. They exactly cancel out. Okay, we get a 1 there, and so the answer here is really just 1/2. And that's our final answer. Okay, so we will look more at this, but please, if you have questions on any of this stuff, reach out to your teacher, because it is going to be super important that you are familiar and comfortable with these trig functions. And later on, it'll be also important that you're familiar and comfortable with these logarithms things too. All right, thanks guys, and we'll catch you later.